Hello everyone, welcome to Chapter 3 in Big Ideas. We're going to be looking at quadratic functions a little bit more in this chapter, specifically focusing on solving the quadratic equations. We'll also look at what's called complex numbers. That won't be until 3.2. But you can see we're going to be dealing with solving quadratic equations pretty much throughout. There's different ways of solving them. 3.1 will be solving the quadratic equations. We'll be doing some solving is when we figure out complex numbers. Completing the square, quadratic formulas, or other ways of solving the quadratic equation. And then we'll be looking at some systems and inequalities there at the end. So for 3.1, we're solving the quadratic equations. We're going to look at three different ways or methods, I suppose you could do, for solving the quadratic equations in this lesson. First, let's take a look at a little, again, cartoon. So here's a far side. This is the curse of artist's block. So it's kind of like writer's block where you can't figure out what to write. This guy can't figure out what to draw. He's got all the way to the point where he just needs to put a head on that animal. You can't figure out what head's supposed to go on that animal. All right, so let's go on to our page 47 in your notes there. Solving quadratic equations by graphing is this says. Now, we're going to look at just some vocabulary. It says quadratic equation in one variable. It's an equation that can be written in standard form. So we've seen standard form before. We talked about a, b, and c being standard form. It was like f of x equals this. But now we're going to see the equation being this part equaling 0. So basically what we're trying to figure out here is what those x-intercepts were. When we did the intercept form, we saw the x-intercepts. And those x-intercepts are the solutions. That's the solution for x. What is x but where they are crossing the x-intercept. So that's what we're going to be looking at is the f of x, which is the same thing as y, is going to be 0 because you can find x-intercepts when y equals 0. So you plug in 0 for y, which is where the f of x was, and that will be 0 equals our standard form then. Root of an equation is a solution. Now there's different ways we might want to say the solutions. The solutions might be asked as far as x-intercepts. Those are solutions of the equation. It might be said as roots, the roots of an equation. That's the same thing as saying the solutions of the equation. Or the third way might be zeros of the equation. So it might say find all the zeros, and that's the same thing there as finding the solutions. Okay, so right there on page 47, you also have this core concept, and these are solving quadratic equations by the three different methods here. Now, there's more than these. We'll see, solving equations by the completing the square and also by the formula. So there's two other methods to solve quadratic equations. Now, we don't always use, one all the time. Sometimes we use different ones depending on how the equation's kind of set up and given to us. Now the first one says by graphing. Now typically I don't use this one that often just because it means you have to graph the parabola, and you can always make mistakes graphing the parabola on a graph, especially if you're writing your own coordinate plane and you don't have a graph paper. So that can be very difficult to maybe understand or where to find those x-intercepts. Now obviously if we're shown a specific graph, if we're shown the graph and we can clearly identify where the x-intercepts are, then we can then state the solutions. We could say, okay, those are the solutions. Those x-intercepts are the solutions. So again, that's another way of asking what the solutions are when it says find the x-intercepts of this equation. It's asking you to find the solutions of the equation. Solve for x. What is the answer for x? Now because x is being squared, that means we have two possible answers. You might have two answers. You might only have one, or you could have no solution. So you have three options that you could have for solutions. No solutions, one solution, or you could have two numbers as a solution. Now, using the square roots is a really easy way. I think it's probably maybe the fastest way to solve a quadratic equation, as long as you have it set up for that. So this is the form that you would want this in, where your variable is squared equal to the number that it needs to equal. So you have u here. Now that u could be x, or it doesn't matter what variable. The d is going to be some number there. And so what you do there to undo the square is you do the opposite operation, which would be taking the square root. That's what it says here. Take the square root of each side. That's going to undo the square of this. So if you have your variable squared here equal to a number, you can then just take the square root of both sides, and it can be very fast and easy. Now that is when you have no bx term. As you can see here, here's our standard form, right? This doesn't have an x term in it, just has your square term only. So if you do not have this other x term here, like the bx part here, if it's just the ax squared and the c, then you could use this using square roots. You could solve for the x squared and then take the square root of both sides. That's the easiest way to do it, I would say. If it does have a bx term, well then you'll be using factoring. This one, it has a bx term here. So if it does have the bx term, you want to check factoring, because factoring will then be the next probably easiest way to solve the quadratic equation. If you have all three terms, or at least these first two, you would want to try factoring. So here's a quick little example of the square roots that I'm talking about. So if you were to write this down just on the side, example here could be x squared equals 9. So your variable squared is already on one side, it equals a number, and you will just want to take the square root of both sides. That's going to undo the square, and now you're going to get x equals 3. The square root of 9 is 3. But now remember, we might potentially have two solutions, right? Most of the time, you're going to have two solutions. So for this case, because we're only getting one number here, it's 3, we're going to put a plus or a minus sign in front of this 3. Every time that you do this step and you take the square root of both sides, you have to include plus or minus that number. So write this down on the side. Always include plus or minus with this step to account for the two answers, because you need to have two answers. You're not just getting one answer of 3, you're getting two answers of 3, because if we were to graph this and use the Desmos calculator, in fact, let me show you that really quick. And here's the Desmos calculator. If I was to type in x squared equals 9, there's the equation. Let's take a look at what this looks like. It's the parabola. Let's go down and see where this, the vertex is way, way, way down there. Okay, so you can see the vertex is down there, but look at where the x-intercepts are. There's one x-intercept, -3. The other x-intercept is at +3. So right there it shows you have not just the 3, but you have also -3. So that's plus or minus 3 for this. So that's why you always need to make sure you account for the two solutions where it's going to cross through your graph in two places there, +3 and -3. Now factoring, underneath this core concept, there's some notes section here. I want us to try some factoring. I'm going to do 3 of these with you. You can go and start writing these down, 1 through 8. You're going to put down there. And I'm going to do 2, 6, and 8 with you, and you can try the rest on your own. Now factoring was a skill you should have dealt with in Algebra 1. They should have talked about factoring quite extensively there. And I'm going to want to just review the factoring here. How do we factor a polynomial? So the first step you would want to look for is a GCF. So step number 1, you want to look for a GCF to factor out. That's number 1. And this one, on these first few, you're going to have a GCF. Like these ones would just have a number that would factor out. This one's going to have a number and a letter that's going to factor out. So we're going to factor out from this. 5 can come out, because 5 can go into 5, of course, and 5 can go into 10. So 5 can come out. And they both have one x, so we can factor out an x. So what's that going to leave us now in our parenthesis? We're still going to have now a parenthesis here, 2 terms. So if I basically take 5x out of this, or divide this 10x squared by 5x. 10 divided by 5 would be 2. If I take 1x away from x squared, it's a 2x. Because 5x times 2x would give me this 10x squared. And then plus, and then 5x comes out completely, so there still would have to be a 1 there. You wouldn't just have 2x, you have to account for the 1, because it's like a placeholder. 5x times 1 would still be this 5x here. We have 2 terms here, we should still have 2 terms in our parenthesis. So you should be able to now do number 1, which you're going to factor out a number there. Number 3, you'll factor out just a number here as well. Going on to 4, 5, and 6, now you have trinomials, and 4 and 5, now you're seeing there's going to be a simple method. So number 2 would be if it's a trinomial, basically you got it down to a trinomial, we want to see if it's just got x squared only. So if it starts off with just 1 x squared, so there's just a 1 in front of that x squared, That's going to be our simple method then. Simple method to factor that. And I'm going to show it to you on this one. First of all, now this would, remember the first thing to look for is GCF. This does have a GCF here. As you can see, it has a 3 in front of x squared, but we're going to factor out that 3. That'll leave us just with a 1x squared. And so when I factor out this 3 here, that's going to leave me with just the 1x squared because I got the 3 coming out. If I say 6 divided by 3, that's going to be 2x here in the middle, and then minus 24 divided by 3 is 8 there at the end. So now we still need to factor what's inside here. It's a trinomial, and it's the simple method kind with just x squared up front only. We would want to keep our 3 in front of this. We have to put this over here, so it's going to equal. So don't mind me, you can maybe put this underneath a little bit, but I'm going to move this over to the side here. We're still going to keep the 3 in front, but now we're going to factor this to 2 binomials. Trinomials always factor to 2 binomials. So here's why it's a simple method, because we're going to break apart this x. There's x squared here. You're going to break it apart and put 1x in front of each of those binomials. And then also you're just going to simply ask a question here. You're going to look at this number 8, the last number, and say, okay, what two numbers multiply to give us 8 that will subtract this sign here? Now, if this was a plus, we would say add. So what two numbers multiply to give us 8 that would subtract to give us this number of 2? So that would be 4 and 2. 4 times 2 is 8, and 4 minus 2 would give us 2. So we're going to put a 4 and a 2 as the numbers in the back. And since this is a negative, they have to be different signs because we're going to subtract them eventually. And this sign here, the bigger number, which is 4 in this case, is going to get this sign here, positive. So this is going to be x plus 4. That's an x minus 2. Now you can always check to make sure, and you should do that, to check to make sure with FOIL. FOIL is where you multiply the first terms. X times x is x squared. Outside we give you negative 2x, and inside give you a positive 4x. You would combine those to give you a positive 2x in the middle. And last terms, 4 times negative 2 is at negative 8 there at the end. So you always want to use FOIL just to check by multiplying back and seeing, okay, did I do that correctly? So now you should be able to do 4 and 5, because those ones you don't need to factor anything out. They are just ready for the 2 binomials. So you just want to factor these to 2 binomials on these with the simple method. Now number 7 and number 8, those ones are a little more complicated because it has a number in front. We're going to call that number a, like it is up here, right? It has a number in front there, ax squared. And this, I'm going to tell you to use the star method. There's a star method. Some of you may have seen this before, or this may be new to you. If it's new to you, I'll take my time. Now we still need to look for GCF. Number 7 doesn't have a GCF because 4, 9, and 5, there's nothing in common there. But over here, 18, 6, and 4, it does have a number in common, and that would be 2 can come out of all of those. Now, since the first number is negative, we really should factor out a negative 2 from all of that. So that way our first term inside the parenthesis is positive, which would be a 9x squared. And then this would also turn to positive here. 6 divided by 2 is 3x there. And now this would be turning to its opposite, negative, and that would be a 2. Okay, so now we need to still factor this trinomial to 2 more binomials. So it's going to end up with still negative 2 here, and then we're going to have the 2 more binomials, just like we did over here. But we're going to do it with a star method, not the simple method, because the 9x squared, now we could break that apart to 3x and 3x, and we will probably end up doing that. But that doesn't always, or it's not always the case there, where it's going to be exactly the same number. So let me show you the star method with this. We're going to draw an X on our paper and then a line through it. You'll do the same thing for number 7. Now the top of this star right here is going to be really remember these are A, B, and C. So I'm going to say, okay, this is our 9. We're using 9, 3, and 2. Remember that's A, B, and C. So A, B, and C. Don't forget about those letters there. That's what they represent. So I'm going to say this is A times C up here. So A times C is up on top, which in this case would be negative 8, sorry, not 18. I'm coming down here. 9 times negative 2, which is negative 18. So it is negative 18. I just had to see it down here. 9 times negative 2. You multiply those two numbers together there to get you the negative 18. So it's A times C. Down below, it's just the B number. So b number only down below, which is in this case 3. And I'm going to put it as positive 3. The top of each side is going to be how this starts off, ax. Ax is going to be the top of each side. So in this case, it's 9x. So 9x on top of this side, 9x on top of that side. And now the ones below this is where we ask the question, kind of the same questions we asked over here. The two numbers that multiply to give us 8, that subtract to give us 2. We're going to do the same thing with these numbers here, the negative 18 and this 3. So what two numbers multiply to give me 18, that subtract to give me 3? And that's going to be 6 and 3. 6 times 3 is 18, and 6 minus 3 would give us 3. And so because it is a negative 18, these are different signs, the bigger one, 6, is going to get the sign of this term, the positive. So it's positive 6 here, negative 3 there. Now we're still not quite done. Now we're just going to focus on these sides. Now it looks kind of like a fraction, 9x over 6. If you can reduce that, you need to reduce that if you can. So this is going to now say, we can reduce this by 3. So this is now going to be a 3x, and this is now going to be a positive 2. So that's going to tell us the first binomial, 3x plus 2, is going to go inside here. Over here, again, we can reduce it by 3, so this is going to be 3x, and 3 goes into this 1, so it's negative 1. So 3x minus 1 is our other binomial on this side, and there it is. There it is in factored form. So these are the factors now, and you can multiply that with FOIL to check yourself to make sure you get back to this trinomial. All right, so go ahead and pause the video and do these other ones. Do 1, 3, 4, 5, and 7. Factor those, and I'll show you the answers here in just a minute. Okay, so hopefully you did finish doing those practice ones there on your paper in that notes section. Here's the answers to those. So check your answers to see if you did these correctly. So there's number 1. You're going to factor out a 2. It's going to then say 4x minus 1 still in the parenthesis. Here's the one we did together. Number 3, you should have factored out 5 because 5 can go into 10 and 25. And then you just still have a 5x here and minus a 2y here. Number 4, it should be these two binomials. Now the order doesn't really matter when you have two binomials. It's x minus 4, x minus 3. You could have put the x minus 3 first and x minus 4 second. That doesn't matter. Number 5, the two binomials should be x minus 5 and an x plus 4. Here's the one we did together on that one. Number 7 is an x plus 1 and a 4x plus 5. And then we did number 8 together again. All right, so this core concept, zero product property, this is what we're going to be now doing. So the factoring method is we would need to do this. We would need to see this basically as an equation. So if I just was to tack on, let's say this number 4 problem right here, if this said equals 0 here, I would need to factor it to these two binomials and keep it equal to 0. And now what I could do is I could take each of these factors and set it equal to 0 separately, kind of like this up here, x minus 4 equals 0, and x minus 3 equals 0. And then solve each of these equations. Now this is just a little one step. I add 4 and x is equal to 4. This one you add 3 and x is equal to 3. That would be the two solutions for our x-intercepts. That would be the two solutions for the quadratic equation. So when it says solve for x, find the zeros, find the solutions, find the roots, any of that, this is what we're talking about. This is where it's going to cross the x-axis on the graph. So that's what we're going to be now looking at on our extra practice. We're going to be doing these equations and factoring them, or maybe taking the square root of both sides on them as well. Okay, so number 1 through 3, it says to solve the equation by graphing. And I'm going to suggest, we're not going to do that because I wouldn't do that myself. I don't usually solve them by graphing, like I've said. I typically only solve these algebraically, so I'm not even going to have you attempt to solve them by graphing. Even though, we could try, and we can definitely, maybe even better would be to go to the graphing calculator. That would be really accurate, and we could probably see the x-intercepts there. But we're looking for the x-intercepts on this to be our solutions. So what I'm going to do is let's go ahead and just solve it, algebraically. How would we solve this algebraically? Well, remember, if there's a bx term right here, negative 11x, we would want to use factoring then for that. So we're going to use factoring on this one. It's the simple method one. There's nothing to factor out. So we're just going to go straight to two binomials. The simple method just puts x up in front of both of these parentheses really easily. And then we ask ourselves the question, what two numbers multiply to give us 24? That would add to give us an 11. So you need to think about the numbers that would multiply to give you 24. Like, well, 1 and 24 would work as far as multiplying to give you 24, but they would not add to give you 11. 2 and 12, you're getting closer, but it would not add to give you 11 either. 3 times 8. 3 times 8 works for 24, and 3 plus 8 works for 11 as well. So that's your combination, is 3 times 8. There was 4 and 6, but that wouldn't work either. It's not going to add to give you 11. So an 8 and a 3, 8 times 3 is the numbers. Because they're multiplying to give you 24, they're going to add to give an 11. Now, if it is a positive number back here, that means they're the same sign. If you're adding them to get this number, then these are going to be the same sign inside here. They're both the sign of the middle term, so they're both going to be negative then in this one. And you can double check with FOIL that makes that correct. And now we want to do what's that zero product property that that last core concept was talking about. So set each of these equal to 0. X minus 8 equals 0 and x minus 3 equals 0. And we'll just add 8 on the first one, so we find x equals 8, and add 3, so x equals 3. So there's our two answers. 8 and 3 are the two answers. They are the x-intercepts. All right, so problem 2, this one we notice there is no bx term. It just only has an x squared in this one, but it is negative. So let's go ahead and try to make this a positive then in that case. So if I was to make this positive, I would want to move it to the other side. So I'm going to have to add x squared to both sides. I would cancel them there, and I'm going to add x squared over here. And I can move this 12 also over to both sides. If I move the 12 over, I'm going to add 12 over to this side as well. So that's going to end up giving me an x squared plus 12 on this side to add with this 13. So you add the like terms here with 13 and 12. So it makes an x squared plus 25 equals 0. And now we can get the x squared by itself by subtracting 25. Now, we could have done this another way. We could have added the x squared, and we could have subtracted maybe the 13 to come this way, and that would have been fine. That would have been given us the same thing. So if you subtract 25 now, it's going to be x squared is equal to negative 25. Now, here's a problem. You cannot take the square root of a negative number. That is no solution on that one. If you're taking the square root of a negative number, what's the square root of negative 25? It isn't 5. Okay, square root of 25 is 5, but the square root of negative 25 is something else. It's actually not even a real number, so that we would say there's no real solutions for this one. So that's going to have to be the answer for number 2. We're going to see if we were to graph this, it's not going to touch the x-axis at all. It will not have any x-intercepts. Okay, for problem number 3, it does have a bx term on this one. We do want to set this equal to 0 first. And that's kind of what I was trying to show you here. It's best if you always have a starting point for these, which means set it equal to 0, and that way you can know what you have to do. So if we set this equal to 0, we're going to subtract the 5x and subtract 2 from both sides. So it's going to give us a 12x squared minus a 5x minus 2, and then these will cancel out here, leaving us with 0 on the right side. And so for this one, it's a trinomial. We want to use factoring, but this factoring starts off with 12, so we would want to use the star method for this factoring. We still want to get it into two binomials equal to 0, but we want to use the star method to figure out what those two binomials are going to be. So you go ahead and draw your star up here, which would be the x with a line through it. Remember, the top of the star is, we're going off of this equation down here, equal to 0. The top of the star is the first times the last, the a number times the c number. That's 12 times negative 2. So it's negative 24 on top. The bottom number is always just going to be whatever the b is. B in this case is negative 5, so b goes down there. And then the top of the star here is going to be exactly the same thing. It's going to be how this begins. It's just the a and the x. So it's just 12x on top of each side. So 12x over there, 12x on the other side. And now you're going to ask yourself that question with the 24 and the 5 here. What two numbers multiply to give you 24? That subtract to give you 5. Well, we already went through where those factors of 24 were. So again, you think about 3 and 8. Would that work here? would the same numbers 8 and 3 work again? Will they subtract and give you 5? 8 minus 3 is 5, so they do work. So we can use 8 and 3. This time they're going to be different signs because we're subtracting them. The bigger number, 8, is going to get the sign of this bottom 5 here, negative. So 8's got to be negative, which means the 3 is positive. Now remember, we're not quite done because we need to reduce our sides if we can. If they're not reducible, then you can just go off of what they say. But right now 12 and 8 can reduce by 4. So 4 goes into 12 3 times, and 4 goes into 8 2 times. And over here, the 12 and 3 can reduce by 3. 3 goes into 12 4 times, and 3 goes into itself 1 time. So now we're going to put our answers down here, or as far as fill in the binomials. The first binomial can be 3x minus 2. So 3x minus 2 from this side. And the other one can be 4x plus 1 from the other side. And that gives us the two binomials. Again, you could double check by using FOIL. 3x times 4x is definitely 12x squared. The back ones definitely give us a negative 2x or negative 2. You would just want to check the outside and the inside and combine them together to see does it give you that negative 5x. Just to double check that factoring was correct. So now at this point we want to use the zero product property. That's kind of the easy part now. Just separate these. So 3x minus 2 is equal to 0, and 4x plus 1, that's going to equal 0. We'll first start solving this one here. So add 2 to both sides. So that's going to give us now 3x equals 2. Divide by 3. So the answer here is 2/3, 2 over 3. So one of the x-intercepts is going to be 2/3. The other one is going to be 4x plus 1 equals 0. Subtract 1, so that's 4x equals negative 1. And then divide by 4. So x equals negative 1/4. Now notice there was a reason why I didn't have us do the graphing, because to figure out the x-intercepts on the graph as a fraction, that's a little hard. Especially the 2/3 would have been kind of challenging to see that that's actually really 2/3 where it's going to go through. So I think that graphing is not necessarily the way to go at all when you're trying to just solve the equation. If they show you the graph where you could use a graphing calculator, then that's fine. But if you're just given an equation, I would go ahead and do algebraically with factoring to solve that. Okay, so in our exercises here, 4 through 6, it definitely says to use square roots. That means this must be somehow set up for square roots. We probably don't have like that bx term in these ones. So looking at number 4, now they don't always use x, obviously. We're using different letters in some of these. They got t's, k's, p's up here on top. We do use x from 7 through 9, but we don't have to always use x. But your variable is the only variable here is the one that's being squared, so we can use then the square roots. So we just need to undo the square on this one, which is ready set up for square roots. It already has the t squared solved for by on one side equal to a number. So we're ready just to go ahead and take the square root of both sides, and that's going to leave us with t equals, and then the square root of 400. Well, the square root of 400 would be 100, but we can't forget to always include a plus or minus. I'm sorry, not 100. What am I thinking? 20. The square root of 4 is 2. Wow. So t is equal to plus or minus 20. So square root of 400, 20. And then put a plus or minus in front of that. All right, let's see if I do a little better on number 5. So the first thing we want to do on number 5 is we want to get this parenthesis with the square by itself. We need to move the 19 to the other side. So we're going to add 19 to both sides. So plus 19 on one side, that will cancel the 19s here, and we're going to have to add 19 to 81. So I'm getting 100 here. Maybe that's what I was thinking, I'm not sure. But I'm getting 100 over here. So the 2k plus 3 squared, that binomial, is now going to equal this 81 plus 19, which is 100. And to undo the square, to solve for k, we have to undo the square next. You're going to take the square root of both sides. So there's always definitely a process you have to go through. You can't just say, oh, I can subtract 3 now. No, you got to undo that square before you can get into anything in that parenthesis. So to undo the square, you have to take the square root, do the opposite operation. So we're going to do that, take the square root of both sides. Now that undoes this parenthesis and the square. We're just going to see the 2k plus 3 now coming out. And over here, the square root of 100 is 10. Okay, did that one all right. But we got to remember to put plus or minus in front of that. So plus or minus 10. Now, here's the problem. We're not done yet. We haven't solved for k quite yet. We still need to get k by itself. But this part equals 10 and this part equals negative 10. There's going to be two separate equations you're going to have to now write. You're going to need to break apart this plus or minus symbol. So one equation we'll use as positive 10. So 2k plus 3 is equal to positive 10. And we need to solve this. So we're going to subtract 3 from both sides. So 2k will equal 7 from 10 minus 3. And then just divide by 2. Divide by the number in front of the variable. So k will equal 7 divided by 2, which is just 7 over 2. So you can leave our answer as an improper fraction. If you want to make that into a decimal, you can. That would be, what, 3.5 as a decimal. Then we want to make another equation with a negative 10 for a second answer. So 2k plus 3 is equal to negative 10. So I'm going to still subtract 3, but when I do, I'm going to end up with a negative 13 this time. So 2k is equal to negative 13, and then divide by 2. So it's negative 13 divided by 2. So that would be like negative 6.5 if we want to get a decimal on that one. All right, coming to number 6, we see some fractions in here. Now, you could get rid of the fractions by multiplying by 7, but I'm not going to do that. I'm going to work with the fractions this time. But if you wanted to, you could multiply by 7 and get rid of all the fractions. What we need to do, since we just have p squareds only, we want to get those like terms together. So I'm going to first subtract this one here. Since it's smaller, I'm going to subtract it over here so that way my p squared term stays positive. So it cancels it from here. It's going to leave me with 0 on this side. And then I got to subtract it also from 5/7. So 5 minus 1 here for the numerators would be 4. So 4/7 p squared is what we're seeing. So it's going to be 0 on this side is equal to 4/7 p squared minus 20. Well, we want to now get the p squared term by itself, so I need to move the 20 to the other side. I'm going to add 20 to both sides. And so it's going to give me now 20 is equal to 4/7 p squared. So at this point, I can now get rid of the fraction by multiplying both sides by 7. So I'm going to multiply by 7 now. And that's going to cancel the 7's out on this side. And over on this side, I'm going to get 7 times 20. Well, 7 times 20 is 140. And it's going to equal, since the 7's canceled here, it's just going to equal 4p squared. So that way, no more fractions, just 140 equals 4p squared. And now we need to get the p squared by itself by dividing by 4. To undo this 4, we have to divide by 4. So now 140 divided by 4, you can do that on a calculator if you want to, but that's going to equal 35. So our p squared by itself is equal to 35. And now we would take the square root to undo the square, just like we did over here on number 1, or no, sorry, number 4. We're going to take the square root of both sides. So taking the square root of 35 and of that p squared, it undoes the square here, leaving me with just p, and it's equal to, and we can't say just the square root of 35, it's going to be plus or minus in front of the square root of 35. Now, if there was a way I could simplify the square root of 35, I would have. If it was the square root of 36, I would have made that into a 6. If it was something else where there was a perfect square that could go into it, then I could reduce it as well. So you want to reduce square roots down to their simplest form and not leave them too big under the radical sign. All right, so 7 through 9, now it's asking us to solve it by the factoring. So here we're seeing a bx term in each one. There's a 12x, there's a 14x. We got a 4x on this side, a 5x on that side. So the first thing we want to make sure we do is get these all at a starting point, which is going to be where they all equal 0. This one's already at that starting point for number 7. It says 0 equals this trinomial. That's the starting point we need for these other two. That way we can then factor the trinomial and see, do we have a simple method or do we have a star method that we need to do? So on number 7, it is just the simple method, so because it has the x squared there. So it's going to say 0 equals the two binomials. And we're going to simply just break apart the x squared and put x in front of both of those parentheses. And then the two numbers that multiply to give me 36, that also add to give me 12, is the same number of 6 times itself. 6 times 6 is 36. 6 plus 6 is 12. So that number times itself 6 and 6 are going to be going in the back of these parentheses. They're both the same number. So far, these are looking exactly the same. In fact, because it's a positive back here, they're going to be the same sign as well. They're going to be both a negative sign. So that way, when we do the FOIL, and I multiply -6 times -6, I get positive 36. And when I do outside and inside terms, I'm going to get a 6x and another 6x combining to give me a -12x. So since they are exactly the same binomial, I'm only going to have one answer. So we only need to solve one of these. Just set 1 equal to 0, x minus 6 equals 0, and add 6 to both sides for our answer. So the only answer for number 7 is 6. So like I said, sometimes you might get only one answer. Most of the time you will have two. That's why on this one we got one number, so it looks like it's the same number, but it's a positive and a -20. So there really is two answers. This one, they're both exactly the same. They're both going to be positive 6, so we don't need to say it twice. The only thing we could say is that it could have a double root. So we might want to say that sometimes, that it would have a double root at 6. Okay, so for number 8, we want to solve, or I should say, set this equal to 0 by moving these two terms to the other side where the x squared is, since x squared is positive over here. So I'm going to subtract 14x from both sides, and I'm going to add 40 to both sides. It's canceling them here, leaving with 0. So on the other side, I'm going to say x squared minus 14x plus 40 is equal to 0. So there's my trinomial. And as we can see, it's just a 1x squared, so it is a simple method. So we can put our two binomials down equal to 0. And we're just going to simply put those x's up in front of both of the parentheses. And then ask ourselves the question, what two numbers multiply to give me this 40 that will add to give me a 14? So there's a lot of different combinations for 40. I mean, 1 and 40 is one combination, but that's obviously not going to be it. 2 and 20, that's not going to be it either. How about 4 and 10? 4 times 10 is 40, and 4 plus 10 is 14. So that definitely is going to work. A 10 and a 4 is the right combination for the numbers. Because they multiply to give us the 40, they add to give us the 14. And because this is a positive here, they're both going to be negative signs. They're both going to be this sign here. So it's a -10 and a -4. And again, you can check this with FOIL just to make sure your factoring is always correct. And then just set your factors equal to 0 separately. So an x minus 10 equals 0, add 10, and that would be our answer. One answer is going to be positive 10. And x minus 4 equals 0, add 4, so the other answer is positive 4. So positive 10, positive 4 are the two answers for number 8. Number 9, we still want to get a starting point here as well. So we want to set this equal to 0. So I'm going to move these two terms to this side since the x squared is bigger here. So I'm going to add x squared to both sides. So I'm going to add it to that one, and I'm going to add it to the x squared term over here, giving me 6x squared. I'm actually going to subtract 4x from both sides to undo that one. So minus 4x, and I'm also going to minus 4x from this 5x, leaving me with 1x here on this side. So I'm going to get a 6x squared, a 1x plus an x minus a 1 equals to 0. So there it is, 6x squared plus x minus 1 equals 0. Now this is another trinomial, but this one's going to require the star method because it does have a 6 in front of the x squared. So let's go ahead and draw our star down somewhere. We can put the empty parentheses down ready for when we want to plug in those empty parentheses with our binomials. So put down your star somewhere. I'm just putting it over here, x with a line through it. So the top of the star is always going to be your a times your c number. So the 6 times the -1 is -6 for on top of the star. The bottom of the star here is going to always be the b number, not the x part, just the number, which is +1. So it's just going to be +1 down there. Now here's where the x's go. They're going to go on top of the sides here. So it's just the a and the x. The a is 6 with an x. So 6x is going to go on top of each side for our top sides there. And then for the bottom of those sides, we're going to use our little question here that we ask ourselves. What two numbers multiply to give me 6? That will subtract. That's why this has to be a sign here so you can see the sign. It's a -6 here. So what two numbers multiply to give us 6 that subtract to give us a 1? Well, there's not too many combinations, either 1 and 6 or 2 and 3, and 2 and 3 is going to be the combination that will subtract to give you 1. 3 minus 2 is 1. So it's got to be a 3 and a 2 for the combinations of those numbers. As far as the signs, they will be different. The bigger one, 3, is going to be positive. It's going to get this sign here. So that's going to be a positive 3 with a negative 2. So now you just want to check your sides. Can we reduce? And we can reduce both sides. 6 and 3 here can reduce by 3. So 3 goes into 6 2 times, 3 goes into itself once. And over here you can reduce by 2. So 2 goes into 6 3 times on the top, and 2 goes into itself once on the bottom. So now here's our binomials. On this left side, we're going to see 2x plus 1 for our first binomial, and on the right side, 3x minus 1 for the second binomial. It doesn't matter what order these are in. The binomials can switch order, but just as long as you have both of those binomials. Okay, so that was the harder part. The easy part should now be to do the zero product property. Separate these and set each one equal to 0. So 2x plus 1 equals 0. We'll go ahead and solve this one by subtracting 1 first and getting 2x equals negative 1. And then divide by 2. So x is going to equal negative 1 divided by 2, which is a negative 1/2 for that answer. So there's one answer. If decimal could be negative 0.5. It's another way you can write it. The other one here, 3x minus 1, set that one equal to 0. Add 1 to both sides, so 3x will equal positive 1, and then divide by 3. So this one's going to be 1/3. So this would be a repeating decimal, 0.3 repeating. So the better answer probably would be the fraction 1/3 on that one. All right, let's move ahead on the next part. I think we're going to go into our joke of the day. So which school supply is king of the classroom? Which one of those school supplies is king of the classroom? Well, that's the ruler, of course. The ruler. Of course, he's the king of the classroom because he's the ruler. Okay, so here on page 49, you're seeing number 10, and it's asking us this question: which equations out of these 5 different equations here, A through E, which equations have roots that are equivalent to the x-intercepts of the graph shown? So let's kind of define some words here. Remember that the roots, that word there, roots and x-intercepts, have the same meaning. They just mean the solutions. So which roots that are equivalent to the x-intercepts, so which ones, they're going to be the same solution. Which equation out of here, or which equations have the same solutions as the solutions that this graph would have over here? And so we want to remember that the solutions over here on this graph are where the x-intercepts are, which is going to be right here at -1 and over here at +4. You can see there's, it's got even the equation up here, y equals x plus 1, x minus 4. This is going to be, you're going to set each one equal to 0. This is going to be -1. You're going to add 4 here and get +4. So our solutions are -1 and 4. So which of these, A through E, there might be more than one, are going to have the same answers, the same solutions of a -1 and of +4. Now I'm going to give you a moment to do that yourself. You're going to go through each one of these and see if you can figure out which of these has the same solutions as -1 and 4. So go ahead and pause the video and figure that out. And once you've figured out which ones have the same ones and which ones don't, then go ahead and play the video to check your answers. Okay, so I'm going to go through this systematically, starting with number A. Does A have the same answers? So hopefully you've already figured out that yourself on all of these for A through E. So the first thing you would want to see is, okay, I could factor out a -2 from this. It's already set equal to 0. It's got a trinomial, but remember with factoring, our first thing to look for is a GCF. 2, 10, and 8, we have a 2 in common, and because this first term is negative, we also want to factor a negative sign out with that 2. So that changes all these signs to positive. So, -2 divided by 2 is just 1x squared. -10 divided by 2 is +5x. -8 divided by 2 is 4. And you could just distribute that back in to make sure you checked your answer right there. Now this would be a trinomial with a simple method, and you want to factor that to see what the two binomials are going to be. So it really doesn't, this -2, we don't need to worry about it anymore. There's no x over there. Here's where the solutions would lie. So this one is a simple method, x and x here. The two numbers that multiply to give you 4 that add to 5 is just a 4 and a 1. They are the same sign. They're both positive. So x plus 4, x plus 1. So is that the same thing as this? Well, no, it's not the same thing. It's almost. It's got this one the same, but it's got an x minus 4, and this one has x plus 4. So nope, A is not equivalent. Equivalent means the same, right? You may want to write that down if you're not remembering what that equivalent word meant. Equivalent word just means they have the same solution. They are equal to each other. B, now this one here, we want to set equal to 0. We're going to subtract the 4 to both sides first. So that way it says now x squared minus 3x minus 4 equals 0. And now this is a simple method factoring again. So we want to put the x's up front and ask yourself what two numbers multiply to give us 4 that subtract to give us 3. And so that's going to end up being a 4 and a 1 again. And the bigger number, now these are different signs because they're subtracting, the bigger one's got to be negative. So it's -4 and +1. Is that the same thing? We have an x plus 1, that matches, x minus 4, that matches. So yes, B, it has the same answers. B is equivalent to this one over here. If we look at C, we can look at it right away. Is it equivalent? It has the -1, it has a +4. Oh, it's just the wrong signs. So no, C, we can say C is gone right away. It's not equivalent, it's the wrong signs. This one would have a +1 and a -4 as solutions, opposite signs. Look at D. This one I would want to use square roots to solve this one. It's just got a squared term with a 4. I want to move the 4 to the other side. So that would say this squared term, x minus 1 squared, is equal to -4. Problem with that, though, is if I take the square root of both sides, I'm going to take the square root of a negative number, which has no solution. So this one couldn't have any solutions. So no, D is out as well. Let's try E last here. Now this one, it needs to, let's get this equal to 0. So first thing to do is just subtract 18x, subtract 24. So we could do that. And I'm going to finish it up here where there's more space here. So I'm going to start off with a 6x squared minus 18x minus 24 equal to 0. So there's a trinomial. Now don't just jump to the star method because you want to look for GCF first. 6, 18, and 24. You could reduce this entire thing by a 6, and that would get rid of your A number. So we could factor out that 6, and now it's just an x squared minus 3x minus 4. And that would be a simple method factoring there. We can just not worry about 6 anymore. In fact, what you could have done here, or even at the very beginning, we could have divided every term here by 6 to reduce this entire equation. And that would have been fine. It would have reduced it down to x squared minus 3x minus 4. And so now we use our simple method factoring on that one. Again, two numbers that multiply to give us 4, that subtract to give us 3. That's going to end up being 4 and 1. And the bigger one is going to get negative. So x minus 4, x plus 1, is it the same? And it is. It matches these two. It's going to match these two solutions as well. So yes, E is another one that has the same solutions. So B and E were the ones that were equivalent to the x-intercepts of this graph here. All right, we have just one more to do, and then we'll be done with this lesson. Okay, so number 11 is a word problem, kind of a real-life problem, and it applies it to a quadratic equation. This is about skydiving, something I've never done and do not plan ever to do. A skydiver drops out of an airplane, that is flying at an altitude of 4,624 feet. Letter A says use the formula h equals -16t squared plus h of 0 to write an equation that gives the skydiver's height, which would be represented by the h letter. So this h, this first h, is the height. Okay. The second h is the height at 0. So that's a little bit different. 0 means when he basically first jumps out of the plane. So 0 would be like when time is 0. So you have your height here, and this would be the height, your initial height, we should say. The starting height is another way of saying it. Starting height would be h of 0. Whenever you see a little something of 0, that's always going to be your starting place or your initial value. In this case, it's the initial height or starting height. And then the t is talking about time in seconds. So how many time, what's the time in seconds here? It says to use this formula to write an equation. So to write the equation is just understanding that the h of 0 is your starting height, and you're starting at an altitude of 4,624 feet. So all we got to do is just substitute this number in for your h of 0 to write an equation. It's that simple, just to say, okay, h equals the negative 16t squared plus that number. Instead of h of 0, we're going to put in the altitude number here, which was the starting height, 4,624. Now, letter B. Is it possible for the skydiver to wait 18 seconds before pulling the parachute cord? Explain. Okay, so how would we answer this question? Well, we're told some time here, 18 seconds. And we do have a variable up in our equation here, that's t, that stands for t seconds. So what we could do is we could say, okay, after 18 seconds, how high is our skydiver? Okay, how high is the skydiver after 18 seconds? So if you plug in 18 for t right here, and then solve for h, that may help you figure this answer out. So let's go ahead and do that. In fact, that's one thing you could do, see what the height would be. That's one way to do it, I should say, is plug in the 18 seconds there and do that. What's another way of doing this? Think about another option that you might have. Well, when would it be too late to pull the parachute cord? Obviously, when he hits the ground, it's too late. He's dead at that point. That's another reason why I'm not going to go skydiving. But that would be when the h is 0. When height is 0, he's on the ground. So we could also put in 0 for h here, and that's going to be the better way to go, I think, on this one, is to plug in 0 for h in this one. Because if we plug in 0 for h, that helps us just figure out a quadratic equation to see, okay, what's the answer to the quadratic? So when I plug in 0 for h here, it's going to be 0 equals this equation. And then we can just solve for t squared, because we can use our square roots to help us figure this out. So I'm going to subtract this number here from both sides. So that's going to now be, actually I'm not going to subtract that number. I'm going to add 16t squared. That would be easier. If you add 16t squared, it puts the 16t squared on this side as positive, and it's equal to a positive. So now I can divide by 16, and 4624 divided by 16, we can do that on a calculator here. 24 divided by 16, that's 289. So t squared is going to equal 289, and then take the square root of both sides. That's what we want to do next. So what is the square root of 289? So I can just hit the square root button right now. That is 17. So t is equal to 17 seconds. So if he does not pull the cord, how long is it going to take him to fall to the ground? It's going to take him 17 seconds according to this equation. So it is too late for him to pull the cord because he's already on the ground at that point. So the answer to this question, is it possible for him to wait 18 seconds? No, the skydiver will hit the ground in 17 seconds. So that's why it's not possible. So I think that's why this is the better way to go. You can solve the quadratic equation using our method of taking the square root of both sides. If you would have put 18 seconds in here and worked this out, you would have figured out that would have been a negative number, because we would have said, okay, 18 squared, let's go and just play that out real quick. 18 squared here is 324. We'd multiply that by negative 16 times 16 is that number, but it would be a negative number. Oops, not minus. I meant to put negative. 5184. So 5184 was the number, negative. There it is. And we would add 4624 to it. Well, we're at a negative 560. That's obviously lower than the ground. So he's through the ground, in fact. That's a little scary. All right, so that concludes our lesson. I'm sorry if you're ending our lesson with a little bit of a morbid way, with some guy dying here on our watch, jumping out of an airplane. But that was the problem they gave us. So concludes a lesson for 3.1. Go on to the 3.1 assignment, and I will see you on lesson 3.2.